So welcome to Replatform to Amazon EKS. As introduced, my name is Ryan Yeager. I'm a manager of solutions architecture. I'm based in Vancouver, and I've been supporting public sector customers for the past 4 years. Joining me on stage today will be Jonathan Oliver, manager enterprise architecture for Landshare Systems. What we're going to talk about today, or what I will start off talking about, is starting off at that 100 level, introducing you to Amazon Elastic Kubernetes Service, or Amazon EKS, and an AWS multi-account strategy. Together, I hope to give you some foundation information that you'll need when Jonathan comes on stage to tell you about their cloud journey. Just at a quick poll, any EKS people here? Anyone use EKS self-managed? Okay, great. So let's start at the beginning. Let's start with talking a little bit about Kubernetes. So Kubernetes simplifies the deployment and management of containerized applications. Kubernetes allows you to configure and run containerized applications at production scale, allows you to integrate with drivers for networking and storage for your applications. And teams choose Kubernetes for its vibrant ecosystem, community, open source APIs, and broad flexibility. However, managing Kubernetes at scale is hard. Running clusters at production scale is complicated and requires trained resources who spend a significant portion of their time managing upgrades, monitoring and scaling the control plane, and deploying and managing the lifecycle of operational software and more. In addition, operations teams need to ensure that the workloads are deployed in a secure manner without exposure to known security vulnerabilities, further increasing the overall operational overhead of running Kubernetes on your own. Customers also want a way to have their containerized applications natively integrate with other AWS services securely and reliably. And this is why a lot of customers have come to rely on Amazon to handle the undifferentiated heavy lifting of security and operating Kubernetes at scale. And when I say that undifferentiated heavy lifting, what I really mean is all that hard work that IT does that doesn't move the business forward on its mission. So let's talk a little bit about EKS. So EKS provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. And by managed service, I mean that shift in that shared responsibility model where AWS takes on more. So for example, you don't have the ability to log into the operating system running the control plane. We take on the management of that. This is different than running Kubernetes on your own. So here are listed on the screen here a few other things that customers have come to appreciate about EKS. First, we do not modify open source Kubernetes. EKS is a fully upstream, certified, and conformant with open source. We support upstream versions for a longer period of time. We support up to 4 versions of Kubernetes, which gives our customers time to roll out upgrades. And as part of this, we even backport patches, fixes, and upgrades to Kubernetes versions. Third, we provide a managed Kubernetes experience where we do a lot of work to select the right Kubernetes version, validate dependencies to provide that security, stability, and operational excellence that customers rely on to deliver. And lastly, we want to make and reduce the complexity of Kubernetes operations. We want to make it simple and boring. So customers choose EKS because it allows them to focus on their business applications that offload that undifferentiated heavy lifting, the tactical operations associated with self-managing infrastructure for application deployments that add no business value. Some of those things that you see in the bottom, things like worrying about the Kubernetes builds, scaling and availability, and infrastructure reliability. Amazon EKS makes it easy to run Kubernetes without having to validate, build, and operate Kubernetes on your own. What are a few other things about EKS to mention? So EKS provisions and scales the Kubernetes control plane, including the API servers and backend persistence layer. And this is done across multiple availability zones for high availability and fault tolerance. It also automatically detects and replaces unhealthy control plane nodes, provides patching for the control plane. EKS integrates with many AWS services to provide scalability and security for your application. So kind of one of those things I mentioned at the beginning that customers ask for. This is what we can integrate with. For example, elastic load balancing for load distribution, identity and access management for authentication, and Amazon VPC, or virtual private cloud, for isolation. and AWS CloudTrail for logging. Maybe one last thing on EKS, and Amazon EKS performs managed in-place cluster upgrades, greatly simplifying cluster operations and allowing you to take the latest Kubernetes features. So where does a Kubernetes cluster run? Well, it runs inside an AWS account. So whether you are an individual or organization, you open an account in the same way. And an AWS account is an isolation boundary for your AWS resources. It is an explicit security boundary. Customers also use it as a container for cost tracking and billing. But organizations don't only have one AWS account, you may have many. And this kind of builds into starting out and building out what's called a landing zone. And the landing zone is a concept to build a secure multi-AWS account environment. But you would begin with what we call the management account, or sometimes you hear it called the root account. And from there, as part of your landing zone design, you'll have many other AWS accounts. So some of the core ones include maybe one for security, where you can have admin delegated designation for guard duty or security hub as an example. That's kind of that far left one that's highlighted there. And another AWS account maybe for centralizing logs. Another one to represent networking, which is that bottom left one with the purple icon representing the transit gateway. And in this account, you may have a direct connect or a site-to-site VPN connecting to on-premise. And with the transit gateway, you can connect other virtual private clouds or VPCs to each other, or you can build routes for isolation such that one VPC cannot reach another. But then as part of your landing zone design, you have to think about the workload accounts. And part of our best practice is designing it for software development lifecycle, having a collection of accounts for development, having a collection of accounts for test and production. So what this happens is if we look on the top left, where we see workload with a green outline representing a virtual private cloud, or VPC, in there you may have teams wanting to build with Kubernetes. So they may deploy their own cluster that sits next to a relational database, or maybe an S3 bucket, or a secrets manager containing keys. And you would issue this to a team working on a project. But this would be in the development collection of AWS accounts. Then you would issue them a second one for test. And of course, then they would deploy another Kubernetes cluster right next to their databases and other AWS resources. And then a third AWS account, where again, they deploy a cluster alongside their AWS resources. So this one project team in your organization may have 3 accounts and now 3 Kubernetes clusters. But that's just one team. If you had a fourth team or n number of teams, the number of Kubernetes clusters begins to sprawl and grow. So part of this, what we're going to talk about is what could you do to build a secure or trusted multi-tenant Kubernetes cluster. And this is kind of what I'm building up towards for what Jonathan will come on stage and talk about. But before that happens, a couple other last things to build that foundation of information I talked about at the beginning is introducing you to IAM roles for Amazon EKS service accounts. Bit of a mouthful there, we'll change that in a minute. But let's start with talking about Kubernetes service accounts. And these provide the identity for processes that run in a pod. And we have what's known as an IAM role. And that is an IAM identity that you can create in your AWS account that has specific permissions. For example, I want to allow read access to my S3 bucket. And what you're able to do with IAM roles for Amazon EKS service accounts is connect them, where you're able to connect an IAM role to an EKS service account. And this is done simply through annotation of the service account with a key value pair, as an example. And then what happens is even in CloudTrail, the logging, is that the service account names become visible in there, so we understand who did what, when, where. And if we look at this illustration, and I'm going to say it one last time here, IAM roles for Amazon EKS service accounts, which I'm now going to shorten to URSA, and pay attention to that one because Jonathan will use that in a few minutes coming on stage. So when I say URSA, I'm talking about this now. With no URSA, the pods that are running in a worker node are running under the context of that one EC2 IAM role. When you choose to use URSA, what's possible now is defining different roles or IAM roles for different pods. And what this is going to open up the opportunity is these roles can be in different accounts. So a service account can assume a role in a different account. And that's going to help build the story and how you can create a trusted multi-account Kubernetes cluster. And with that, I want to introduce my customer, Jonathan Oliver from Landshare Systems, to come up and tell you their story on AWS and Kubernetes.
Thank you very much, Ryan. That was an excellent introduction to this. So as Ryan mentioned, my name is Jonathan Oliver. I'm the manager of enterprise architecture at Landshare Systems, all the way out in Vancouver, BC. And I'm really happy to be here today sharing with you our AWS cloud journey with that lens on EKS, Kubernetes, and our lessons learned, and hopefully help all of you out. I'm also really proud to say I'm joined with three of my colleagues today who made the long trip out, so I'm happy that they did all the work on this, so it's nice to be here as a team for this. So, Landshare Systems, probably you're thinking, who is Landshare Systems? I wouldn't blame you for saying that. Landshare Systems is a wholly owned subsidiary of the Land Title and Survey Authority of British Columbia, or LTSA is what we generally call it. The LTSA is a statutory corporation publicly accountable for the purpose of maintaining and authorizing the administration of land title records, real property in the province of British Columbia. If you own property in British Columbia, you can thank the LTSA systems for managing that. Additionally, survey is also handled by the LTSA. That's the fun part of it. The land title side would be the legal records behind things. Survey is the nice pictures as to where everyone's boundaries are. So all of that is managed by the LTSA. Landshare, our responsibility is to develop, design, and operate LTSA's mission-critical systems. So we're the technology branch, if you wish, of the LTSA. So our story, where do we start? Well, we go back. Not all the way back, though. If we went all the way back, we'd be talking books and quill pens and inkwells and maybe not inkwells, but we're not going that far back. We're also not going back as far as our time on the mainframe. Many of you may still operate workloads on the mainframe. We left the mainframe about 15 years ago in favor of the architecture that you see on your screen right now. Very classic architecture, very traditional, I should say. The three-tier architecture: our web server, our application server, our database server. This is a simplified version of it. We have a lot more than this, but they traditionally fell into this pattern. Now, there's a reason why the application server is drawn so massive on this screen, is because we've evolved. The LTSA services have evolved. We've brought out many new services. So we would add them to our application server, and it would get bigger and bigger and bigger. We made the decision about 4 years ago to adopt containerization. We said our apps, Java apps running in Tomcat, we said, let's containerize these. Containerization is the buzzword. We recognize the benefits of it. So let's do it. So with containerization comes operation. How do I operate? How do we run our containerized workloads? Kubernetes was pretty fresh on the scene. It's amazing how time flies. And we started looking into Kubernetes and looking at various distributions of Kubernetes. And as you can see on the screen here, we decided on the OKD, or the Origin Kubernetes distribution, the upstream to OpenShift at that time. So the plan was containerize our many apps off our giant app servers and replatform those workloads over into our OKD clusters. Because you don't just have one cluster on-prem, right? You have your dev, your test, your prod, your DR, all of that on-prem, on VM. We were running VMware on our private data centers. So we started working to that, but it was pretty slow going. We containerized some apps pretty quick, but the slow going came from, if you remember back to what Ryan was saying earlier, that undifferentiated heavy lifting. That hit us square in the face. Friends don't let friends manage their own Kubernetes. We learned that. We were spending all of our time managing our cluster. Learning Kubernetes is one thing, but learning Kubernetes and managing that control plane, learning how to upgrade it, patch your servers, not have downtime, get our ingress working. That was such a challenge for us. We could never get Helm working for whatever reason. Persistent volume claims, which were so essential for the work we were doing, I don't think we actually got a persistent volume claim working reliably in our cluster. So these were some of the problems that we were fighting, that we were dealing with. Instead of driving our business capabilities forward, containerizing our apps, getting that freedom to orchestrate them in the cluster, we were so stuck on this. So something had to change, right? Otherwise, I wouldn't be up here presenting. The change was we made another decision in our organization, and that was to move to the cloud. Specifically, we decided to move to AWS. And with that came a replatforming to the cloud. So I'm going to talk a bit about our replatforming to the cloud, and of course, I'm going to be focusing in on EKS, but you have to understand the context as we go on this as well. So this picture shouldn't look that much different. Different icons, AWS logos on things. The same 3-tier architecture in place. So it was a bit of a lift and shift that we did for a lot of our workload. Our web server, our application servers, our database servers. They were lifted and shifted in. We changed the underlying operating system on them, but the apps were the same. We introduced EKS at this time. So instead of staying with self-managed OKD that we had on-prem, we went all in on EKS for this. Another massive decision. I can't understate this. I can say it very quickly, but the amount of effort and the commitment that we put into place to finally adopting our infrastructure as code, as pictured down the left side on that slide. On-prem, we had pets. If you use the pets versus cattle analogy, some of those pets were very old, even if you use pet years, or human years on them. The same names for a decade on some of these servers. We introduced infrastructure as code to drive everything toward containerization. You'll see that more on the next slide. But we introduced Ansible to script up the configuration of all those servers. Those servers that previously had just been played forward, each release, each patch, each everything, we just kept playing our servers, our pets forward. But now we built from the ground up with Ansible our servers, our EC2 instances. Terraform, we were brand new to Terraform, but we absolutely loved it and still absolutely love it for having our entire infrastructure controlled and declaratively in Terraform, including our Kubernetes clusters. And Helm. Helm kind of goes without saying. It's kind of de facto, you should be using Helm with EKS. I think I mentioned earlier, we never actually got Helm working on-prem, or it was kind of limping on-prem for whatever reason. Maybe we just didn't know what we were doing. Just like it says at the bottom there, everything just works. So we put a lot of work into that infrastructure as code, learning cloud. This is cloud adoption, so there was a big learning curve for us along the way. But one thing we kept repeatedly seeing was, as we turn on that EC2 instance, our stuff just kept working. And now more importantly, going to the cluster, the EKS cluster, all the woes we had on-prem, I can really sum it up with just saying it just worked. Our ingress wasn't a problem. Helm worked right out of the way. I think it took us 10 minutes to do our first persistent volume claims successfully. We brought in the Elastic File System, Amazon Elastic File System, to bridge that gap of our applications that had a shared file system, actually allowing us to containerize them and move them to the cluster, to the Kubernetes cluster, but still have them working on the same file system as our application server apps. We didn't know how we were going to do that on-prem. Yes, there's solutions, but we just didn't know. We were too busy with our on-prem clusters. So yes, we had to learn, but the learning was straightforward, and there weren't really that many setbacks on that learning curve. It was very, very enjoyable. So this is a pretty high-level view of what we did here. I'm going to move now to a deployment diagram. Again, it's still pretty high level. I'm abstracting over a lot of things on here. There we go. But I just want to tell the story of what our deployment architecture looks like in AWS. So right out of the gate, I think your eyes should be drawn to north and south, top and bottom on the diagram, 2 availability zones. We took advantage of 2 availability zones in our solution. Formerly, we had a data center on the west and a data center on the east. We didn't have availability zones. We had disaster recovery. So now that we came into the cloud, we started talking in terms not of disaster recovery, but high availability, resiliency, availability, how we can achieve greater metrics on that. And I'll talk through this diagram a little bit because, and a disclaimer, from here on, my diagrams just get more and more cluttered, so I'm going to talk you through them. But a key point to take away on here is the high availability, the multi-zone, and the containerization. So there's 2 elements of containerization here. The first is somewhat obvious, EKS. Our workloads are containerized, Docker containers, and we deploy them onto Kubernetes. On the right-hand side here, remember I talked about our heavy investment into our infrastructure as code. We don't deploy code to servers anymore. We run our infrastructure as code and produce Amazon machine images, AMIs, which are Amazon's building block of original containerization. So now, remember I was saying we had our pets on-prem for our servers? Our deployment processes, our release processes involve us incubating our AMIs, and then go live involves us replacing our previous EC2 instance and bringing in that AMI. But pretty standard approach in AWS cloud computing. It was new to us, but I want to call into the quote containerization aspect of that. So given the nature of our applications, these are pretty old. Some of our apps are pushing 18 years old here. And many of them are not capable of running redundantly in a highly available fashion. So we have a primary zone. So we have CA Central 1A primary and CA Central 1B as our failover for our EC2 instances. But our Kubernetes workloads, the EKS, the Kubernetes orchestrator in there finds the healthy node for it, and we have automatic failover for the apps that can't run highly available, but then also automatic load balancing to our newer applications running in there. But I do have a confession to make on this diagram. It wasn't this straightforward. Do you remember the sprawl on the accounts slides that Ryan was showing? We experienced that. This is more like what we encountered. In fact, actually, it was worse than this. This is maybe production. We had 3 product teams all working together in production, all working with each other, all having their own stack, albeit identical because of our infrastructure as code now, which was awesome. But can you imagine deploying to this, making a resource change? Deployments releases were absolutely brutal for us. So the undifferentiated heavy lifting was gone, but now we were just in dependency mayhem. So this diagram, when I drew it on my small laptop screen, I thought that was more complex enough. On the big screen, it doesn't look so bad. This is 3. we have over 30 accounts, and we had over 12 clusters that we're dealing with. So multiply that. So we had to do something. We had to do what we call crawl back the sprawl. So that's what we did. So this is a complex diagram. I'm going to explain it. We consolidated our infrastructure on here. So let me get right into this. I'm going to go from the bottom to the top, and I'm going to go left to right on this diagram. So you can see at the bottom of this slide here, there's the two big boxes at the bottom. The shared networking account and the security account. I mentioned those 30 some odd accounts before. Each of those 30 some odd accounts had a VPC in them, endpoints, a transit gateway, NAT gateways, internet gateways, you name it, everything was there. So very complicated. But what we did is we consolidated those down to, as you can see, non-prod, prod. Two networks on this diagram here. So with each of those VPCs, yes, you have your NAT gateways, you have your transit gateway, your internet gateways, but we're talking a very small number in compared to the sprawl that we had before. Also of note, because of our reduced number of networks now, it made it very easy, and as it turned out, it was essential for us to put in, on the right here in the security box, a next-gen firewall. It was very straightforward for us to work with Fortinet for this firewall to intersect and inspect our north-south traffic, as pictured by that pipe going across the middle in the diagram there. So this is just network infrastructure, but now we could finally have our corporate IT team focusing on network because they were the network experts instead of having all the accounts having to deal with that. Then so you'll notice both vertical channels are identical, so I'm just going to talk to one of them. They're non-prod and prod. That's IAC again for you. They're identical. So I'll talk to the prod channel on the right here. As you go up from the shared networking, we have our platform team account. I have a platform team that does, we haven't cut out all our undifferentiated heavy lifting, but we have consolidated platform resources such as a Kubernetes cluster, EKS, under the realm of our platform team, our DevOps platform. We're going to talk a lot more about that in the next couple of slides. But you can see there's two of them, not 12. There's two. Pictured above that in the stack of accounts, those are what we call consumer accounts. They're our product teams, users, consumers of the cluster. So what we've done now, though, is we've gone from having a cluster per team, cluster per product, where there's a lot of liberties you can take in that environment, to now consolidating that down into a multi-tenant environment. So consolidation is great, but this introduced a lot of new requirements for us that we had to solve. So the Amazon EKS multi-tenant needs that we had. I'll start at the bottom on this slide. It's not even a diagram, and I'm guiding you through it. The manifesto that we had is that our consumer accounts, our product teams, they needed to have full control and free reign on their Kubernetes workloads, and not being reliant on that platform team that I was mentioning and that you saw on the diagram there in the design. They needed to be able to innovate as fast or as slow as they wanted or needed to. So to do that, we needed to segregate their workloads at the namespace level, inside Kubernetes, segregating their workloads at the managed node group level as well. We wouldn't want one product team's services to take out a node because they overloaded it from another product team. So we segregate the workload, have to segregate them that way. We needed to restrict our consumer accounts inside their namespace. It's important in multi-tenant. They have to stay inside their sandbox. But also, maybe more importantly, we now had to restrict them from any cluster-related actions. That's the platform team's responsibility. They can live inside their namespace. And now we're going to bring Ursa into it, the IAM roles for service accounts. I can't say it without seeing it in front of me. We need to allow those EKS workloads to work with the resources that would be owned, going back to the previous diagram, in that stack of consumer accounts at the top there. So workloads were going to be in the platform account because that's where the Kubernetes cluster was. That's where their node groups would be. But their DynamoDBs, their S3 buckets, their keys, their secrets, all of anything else, all of that is going to be in their consumer account. So pretty well every service you deploy needs one or all of those things. So we need to connect those. That's where Ursa comes into play for that. So now we're going to go to another complicated slide, and we're going to take our time on this because this is our architecture for how we've designed our multi-tenant EKS cluster. So we're going to walk through this. We'll start from the outside, and then we're going to go in. We'll do the same thing. We'll go left to right. Again, try to keep it consistent. So from the outside going in, we have two accounts on the screen here. The first, the platform team account. I think I've talked about that enough. You're getting the picture on that. That's where our Kubernetes lives. On the right, only one shown here, but that's repeated n times, is our consumer account or accounts on that. That's where their resources would live. Going back to the left, inside the platform account here, at the top you can see our managed node groups. We segregate platform node groups from tenant. So now I'm using the term consumer and tenant almost synonymously here. Sorry for the inconsistency there. So our tenant inside the Kubernetes cluster, they get their own managed node group. Going inside the cluster now, you see that we have our platform namespace. Really, it's platform namespaces in there. Inside there is where we have our team, our platform enabling services. You can see we have our CI/CD runners in there. Helm exists in there. Our build artifact repository in there. Everyone will be different. That's what ours looks like, skipping dozens of them for simplicity. Below those are some really key points to take home here. If you recall, Ryan mentioned that Amazon EKS runs the vanilla or upstream Kubernetes distribution. So as such, that's what you get when you stand up your EKS cluster. But since you're already in AWS, you're almost guaranteed to wanting to be interacting with AWS services. For example, ingress. On-prem, the ingress controller would be maybe an Nginx ingress controller, and you have all the fun with that. Inside AWS, with EKS, Amazon provides a driver. It's called a CSI driver for an ALB ingress controller, so application load balancer. So direct integration with Amazon's EC2 ALB for your ingress. Powerful. I won't go into the others, but they're all equally as powerful. Because I want to draw your attention to the bottom right corner of those beautiful rectangles that I've drawn. HNS. HNS stands for hierarchical namespaces. That's not an AWS thing, although AWS may have contributed to it, I don't know. That's part of the Kubernetes special interest group for multi-tenancy, trying to solve the problem of how do you have multiple tenants in here able to manage their namespaces. It does exactly that. So by providing that service at our platform level, shifting into our tenant namespaces now, our platform team provides a tenant namespace to our consumers, but if they want more namespaces, which is a cluster action, if you recall me saying before, they can't have any cluster actions. That's a security risk for them. So how do they get another namespace? That's where hierarchical namespace comes in. They can create their own sub namespaces, manage them, put their workloads in them however they see fit. Importantly, not needing to involve our platform team to do it. They have free reign on it. So that's our Kubernetes structure there. So now we're going to get into, as a tenant, what does it look like for you in there? So inside the tenant, right in the dead middle there, inside that tenant namespace, inside Kubernetes, you deploy your services. So services under a service account with your pods. So how does that work? So in the diagram here, I'll take the first box in there that says service account 1. So what we do is we have a service account inside Kubernetes for that workload, that service. And it's service account, not services account. We do a one-to-one mapping for that. Each service gets its own service account. And then depending on what your needs are, you have as many pods as necessary for your needs in there. Now we're getting into URSA, because as we know, no workloads really just run without any interaction with resources, or very few do. So you can see that dotted line between the service account box and the beautiful hard hat there that says SA1 on there. That hard hat there is indicative of an IAM role. That IAM role is a cross-account role that is linked to that service account via URSA. So Ryan mentioned there's an annotation that goes on the service account in Kubernetes, in EKS, I guess specifically EKS in this case, that makes it so that when you deploy that service under that service account, those pods, they start running with the role SA1. And that's a key point here. They run with the SA1 role, the IAM role from the consumer's account that they own, they maintain, they control the policies on that. As opposed to, you saw Ryan say earlier, if you don't do that, it assumes the role of the nodes, which are hopefully locked down so they can do absolutely nothing as a security prevention, so security step. So what that enables now is your workloads, your pods, in your service account, under your service account, in your tenant namespace, in the shared multi-tenant cluster, they can now securely access whatever policies you put in place on that role. As you can see, a standard example there of Secrets Manager, KMS, buckets, DynamoDB, Elastic File System. This is the holy grail that we've gotten to here. It's secure by nature, security by default on here. We've given our consumer accounts, we've given our product teams and enabled them what they need to innovate and do whatever it is they need to do inside this cluster. We're pretty proud of this. If you have any questions, feel free to ask any of my 3 colleagues. Don't ask me, ask them after the session. They built it all. I'm just the one up here giving the presentation. So in summary, what real gains have we achieved here? I know we've said undifferentiated heavy lifting a lot of times here. I saw the survey that Ryan took as well, who's running EKS as well. Perhaps not many. I don't know how many are managing your own EKS. Maybe you can relate if you are. But we freed up at least 1 FTE who is spending all of his time administering to the best of his ability our numerous on-prem OKD clusters. So we freed that up. There was a lot more because it was a cross-team effort as well, so it was probably a lot higher than that. That sprawl that I was talking about, that is when we reduce that, our operational costs drop by 20%. So instead of having all of that duplicated effort or duplicated cost for redundant services, we brought that down, saved 20%. On-prem, I didn't say this earlier, on-prem, we never were actually able to add a node to our cluster, just couldn't figure it out. I like to think we were fairly smart, but we couldn't add a node. So we ended up tearing down our cluster and replacing it anytime we wanted to add a node on-prem. In AWS with EKS, it was so simple to add a node, scale it out with the auto-scaling managed node groups there, with the elasticity that gives us. Our migration to the cloud, we hit 100% uptime for the first 4 months. And that was amazing for us, because we averaged maybe 98% on-prem before that. That's a huge jump for us. Production deployment, I don't know how many developers are in here, but you might, or DevOps, you'll cringe. Our world on-prem, the deployment times took at least a day. It took all day to do a deployment. It was painful, sometimes the whole weekend, always on a Sunday at least. So now we've managed to bring that down. Still not as low as we want it to go. We're still working on that, but we're averaging about 2 hours now. And that comes from the next point here. Our deployment experience is consistent across our environments. When our DevOps are running the releases and deployments into dev, into test, staging, UAT, it's the same IAC, it's the same process, the same procedure for everything. So now going to production, all of those kinks have been worked out. Those pets are gone. It's all the same thing working its way up through the channel. I know this is somewhat obvious to say, but we finally realized it when we made this change. And then finally, we make extensive use of Amazon EFS, shared file system. The persistent volume claims that we use, I don't know if your workloads are anything like ours, but we have a lot of older apps that heavily rely on the same directories on the same file system, even just to share files and pass them through. It's embarrassing to say it, but I'll say it. So we had to provide a means to allow for that. The Elastic File System with EKS in conjunction with we still have our big application server. It's a lot smaller now as we're moving our workloads over, but that allows us to seamlessly work together there. And there's many more benefits that we've achieved, but we're restricted by time here. So I hope you enjoyed the journey. Hopefully you can see the pitfalls the pits that we fell into. Avoid them, please. And hopefully where we're at is somewhere you can maybe start instead of having to go through the bumps that we have. We've learned a lot. We've had a lot of fun along the way, and we're really proud of where we've gotten to. So thank you for listening.
Thank you, Jonathan. You've probably seen these slides already, but before we get into that, I just want to give a special thank you to Jonathan and Landshare. He's a customer just like many of you. Thank you for coming, Jonathan and the team.